NASA's Pilgrim 1 spacecraft, which currently holds the record for the farthest distance traveled by any human-made object, has captivated the world for nearly half a century. Since its launch, Voyager 1 has sent back crucial data from the farthest reaches of space, expanding our knowledge of the cosmos. However, the spacecraft's ongoing transmissions have recently encountered mysterious anomalies that have puzzled scientists. These strange signals have sparked intense debate, leaving the scientific community to wonder whether they are simply a malfunction or could indicate something far more extraordinary, perhaps even extraterrestrial phenomena. Join us as we explore these perplexing transmissions and consider what might be hidden in the vast expanse of space. Humanity's drive to explore the unknown has always propelled space exploration. This innate curiosity led to the creation of ambitious missions like Pioneer 1 and Explorer 2, which were some of the most daring space missions of their time. On August 21, 1977, the launch of Explorer 2 from NASA's Kennedy Space Center signaled the beginning of a transformative era in space exploration. Shortly after, on September 5, Explorer 1 followed, embarking on a path that would take it on a trajectory toward the outer planets, significantly affecting its orbits and mission outcomes throughout its journey. These two spacecraft, each weighing about 720 kilograms, roughly the size of a small car, set off in different directions and at varying speeds. On December 15, 1977, a critical milestone was reached when Explorer 1 outpaced its twin, owing to the different courses they followed. Since then, Explorer 1 has become an invaluable tool in expanding our understanding of the universe, offering insights that have changed how we perceive space. Before diving into Explorer 1's most recent groundbreaking discoveries, let's revisit some of its earlier significant achievements. In 1978, while it was about 265 million kilometers from Earth, Explorer 1 successfully captured detailed images of Jupiter. By January 1979, it completed a remarkable 100-hour mission, producing a time-lapse video of Jupiter's rotation. This series of 3,750 images provided unprecedented views of Jupiter's turbulent atmosphere and complex features. During this mission, the spacecraft discovered a previously unknown ring surrounding Jupiter and also identified two new moons, vastly enriching our understanding of the gas giant's intricate system. To ensure its safe journey and avoid any collisions with Titan, one of Saturn's moons, the spacecraft executed a series of correction maneuvers. After these, the mission's focus shifted beyond the planets of our solar system as the spacecraft were redirected toward interstellar space, traveling at a staggering rate of 325 million kilometers annually. In January 1990, Explorer 1 embarked on its mission to explore interstellar space, continuing its journey beyond the solar system. During this phase, the spacecraft achieved several remarkable feats, including the discovery of 4 additional moons, Mimas, Enceladus, Tethys, and Rhea, and capturing some of the most iconic images of our solar system's outer realms. On February 14, 1990, at a distance of around 6 billion kilometers from the Sun, Explorer 1 took its famous family portrait, capturing stunning images of the inner planets. This collection of 60 photographs joined the spacecraft's portfolio, which included a total of 670 images taken during its flyby of Neptune. Explorer 2, meanwhile, achieved its own remarkable milestones. During its mission, it recorded wind speeds exceeding 13,100 meters per second, fastest recorded winds in the solar system, giving scientists essential insights into Neptune's distant atmosphere and its moon Triton, where surface temperatures reach a freezing -391 degrees Fahrenheit, making it one of the coldest spots in the solar system. Triton also exhibited ice volcanoes, ejecting nitrogen gas and frozen particles up to 5 kilometers high, offering an exciting new perspective on the moon's features. These extraordinary findings deepened our understanding of the diverse and dynamic environments in the outer solar system. The contributions of both Explorer 1 and Explorer 2 have been nothing short of revolutionary. Their missions uncovered previously unknown details about the moons of Jupiter and Saturn, which had been considered dormant. These findings have reshaped our understanding of the geologically active nature of these moons. In particular, Explorer 2 made history by being the first spacecraft to fly by both Uranus and Neptune, an achievement that has yet to be replicated. NASA employed a variety of innovative strategies to extend the missions of these pioneering spacecraft, such as shutting down non-essential systems to conserve power. The mission is expected to continue until 2030, marking the end of an era for the engineers and researchers who have dedicated themselves to this extraordinary journey. The design of Explorer 1 and Explorer 2 reflected cutting-edge engineering. These spacecraft were built to rotate slowly, minimizing blurring in the images they captured as they moved through space. Even before reaching the outer planets, the spacecraft began transmitting detailed images of Jupiter, revealing its swirling clouds and iconic Great Red Spot, a massive storm that has fascinated scientists for decades. However, the most thrilling discovery was the identification of active volcanoes on Jupiter's moon Io. The spacecraft's instruments picked up unusual signals from the moon, which were later confirmed by images showing towering volcanic plumes and a surface marked by intense eruptions. One of Io's volcanoes erupted with a force 1,000 times greater than Mount St. Helens, covering an area nearly as large as France. As the spacecraft continued on their journey, they were eventually powered down to conserve energy before embarking on their voyage into interstellar space. Remarkably, the images they captured did not include Mercury or Mars due to technical limitations. NASA later launched other notable spacecraft, including Pioneer 10, Pioneer 11, and New Horizons. On February 17, 1998, Pioneer 10 surpassed Pioneer 11 to become the farthest spacecraft from Earth. Despite this, Explorer 1 continued its solitary journey for an additional 14 years before entering interstellar space on August 25, 2012. The success of these Explorer missions was largely due to the innovative use of gravity assist maneuvers, which helped propel the spacecraft to their destinations while conserving fuel. Rather than relying solely on their own propulsion systems, the spacecraft employed gravity assists, maneuvers that involve using a planet's gravitational pull to increase speed. This technique allowed them to travel vast distances without depleting their fuel supply. As Explorer 1 approached Jupiter, the planet's immense gravity accelerated the spacecraft. Such precision was necessary to avoid disastrous deviations in trajectory or speed, and these maneuvers allowed the spacecraft to successfully navigate their journeys through the solar system and beyond. Explorer 2 also made use of gravity assists from Jupiter and Saturn to reach Uranus and Neptune, demonstrating the efficacy of this technique. Reflecting on the immense achievements of these missions, we eagerly await further insights into the recent anomalies detected by Explorer 1. The Voyager spacecraft continue their missions beyond the known limits of our solar system, exploring the mysteries of Jupiter, Saturn, Uranus, and Neptune. Explorer 1's time-lapse images vividly showcase 10 eruptions on Jupiter, in addition to revealing new moons and a previously unknown ring around the planet. These discoveries have significantly improved our understanding of Jupiter's system. Similarly, Explorer 1 identified 4 new moons of Saturn, Mimas, Enceladus, Tethys, and Rhea, and captured beautiful photographs of the planet and its rings, offering fresh insights into its complex system. The spacecraft's groundbreaking visit to Uranus and Neptune provided valuable data on their environments and moons, enriching our knowledge of the outer solar system. Following their planetary missions, both Explorer 1 and Voyager 2 set their sights on interstellar space, where they continue to collect invaluable data. This ongoing research is expanding our understanding of the universe beyond our solar system. As we await more details on Explorer 1's unusual signals and their implications for our understanding of the cosmos, the remarkable journeys of these spacecraft continue to inspire awe and wonder among scientists and space enthusiasts alike. Their achievements persist in advancing our collective knowledge and pushing the boundaries of space exploration. The Voyager missions have provided us with unparalleled insights into the solar system and beyond. Along with iconic images and scientific data, these missions also carry a message, an artifact designed to communicate Earth's story to potential extraterrestrial civilizations. The Golden Record contains greetings in 55 languages, music from various cultures, and sounds of nature, such as thunder and whale songs. This message in a bottle represents humanity's hope that one day, intelligent beings beyond our world may find it and understand our essence. Explorer 1 and Explorer 2 were equipped with a range of scientific instruments that have revolutionized our understanding of space. These included magnetometers, plasma wave detectors, and imaging systems, which provided critical data on space phenomena. For example, the magnetometers offered valuable insights into the magnetic fields of Jupiter, Saturn, Uranus, and Neptune, revealing the interactions between these planets and their environments. The plasma wave detectors helped us understand the behavior of the solar wind and its effects on planetary atmospheres. One of the most remarkable achievements of the Voyager missions was their ability to measure the heliosphere's boundary, a region filled with solar particles and magnetic fields that surrounds our solar system. As Explorer 1 approached this boundary, it detected a shift from the solar wind to the interstellar medium, providing important data about the structure of the heliosphere and its role in shielding Earth from cosmic radiation. The spacecraft revealed a distinct boundary, known as the termination shock, where the solar wind slows down and becomes denser. Beyond this, the heliosheath forms, where the solar wind interacts with the interstellar medium, creating a dynamic and complex environment. Explorer 2's journey has also contributed greatly to our understanding of the outer solar system. Its flybys of Jupiter, Saturn, Uranus, and Neptune provided crucial data, especially its observations of Uranus' magnetic field, which was found to be tilted in a way that challenged existing models of planetary magnetism. These discoveries have sparked further investigations into the magnetic fields of other planets. These missions have not only advanced scientific knowledge but also sparked public interest in space exploration. The stunning images of distant planets, along with the personal stories behind the spacecraft's missions, have inspired millions worldwide. The breathtaking photographs of Saturn's rings and Jupiter's volcanic moons have become iconic, encouraging the next generation of scientists and explorers.